Today we are going to look at exploratory factor analysis for scale development. We are going to look into using principal component analysis, which is one of the most used methods for exploratory factor analysis. Now, what is factor analysis? Factor analysis is used as a data reduction technique. Factor analysis takes a large number of variables and reduces or summarizes it to represent them in different factors or components. For example, you are interested in measuring service quality in a university and you ask students 30 or 40 different questions. Through factor analysis, what you can do is you can group those 30-40 questions into different factors or components. For instance, teaching quality, for instance, administration quality, for instance, leadership quality, or other quality related factors. Now, factor analysis is a method for investigating whether or not a number of variables of interest are related to a smaller number of unobservable latent factors. This is done by grouping variables based on intercorrelations among set of variables. And what it does is it groups those variables, those items that have good or significant correlation among them. So they make one single factor. So on and so forth, other factors are made. A common usage of factor analysis is in developing objective instruments for measuring constructs which are not directly observable in real life. In majority of the cases, factor analysis is used for scale development to identify the underlying factor structure for a particular construct that you want to measure or you want to develop a scale for. Factor analysis technique mainly examines the systematic interdependence among set of observed variables, those items on which the questions are asked. And the researcher is mainly focused on determining the base of commonality among these variables. Factor analysis has been extensively used in research for data reduction and summarization. The main objective of factor analysis is to summarize the information contained in a large number of variables in a few small number of factors. So what it does is it actually provides you with a summary of factors based on those 30-40 items that you initially collected data on. It gives you a more clear picture of how a construct should be represented. How well the items go well together in case we are building a new scale. So there are two types of factor analysis, EFA and CFA. When applied to a research problem, these methods can be used to either confirm a priori established theories or identify data patterns and relationships. Specifically, they are confirmatory when testing the hypothesis. So if you are testing a hypothesis, what you are doing is you are doing a confirmatory factor analysis. And exploratory, it is exploratory when they search for latent patterns in the data. So what sort of factors exist in service quality in higher education? What are the components of service quality in higher education? So asking those 40 questions will lead you to define or establish the components of service quality in higher education. Now this is when the data, in case there is no or only little prior knowledge on how well the variables are related. So we do not know what the components of service quality is. For example, in scale development, we do not know what the components of servant leadership in higher education are. So you are actually exploring what servant leadership could be in higher education or service quality could be in higher education. When exploratory factor analysis is applied to a data set, the method searches for relationship. Variables with high correlation are grouped together. So items that have high correlation are grouped together. So what is meant by this, we will be saying this practically through a software. Between the variables in an effort to reduce a large number of variables to a smaller set of composite factors, that is combination of variables. The final set of composite factors is a result of exploring relationship in the data and reporting the relationship that are found, if any relationships are found. Now, what are the basic terminologies that you will come across when doing factor analysis? First is Kaiser-Meyer-Olkin KMO measure of sampling adequacy. This is one of the assumption, an important assumption of exploratory factor analysis. The KMO measure of sampling adequacy, as it's called, is an index used to examine the appropriateness of factor analysis. This statistic shows the proportion of variance for variables included in the study is the common variance. A high value of statistics from zero point 0.5 to 1 indicates the appropriateness of factor analysis for the data in hand. So in simple terms, it shows that whether or not the sample that you have at hand is adequate for factor analysis or not. So if a value is below zero point 0.5, obviously this shows that this is inappropriate for factor analysis. Another important assumption is Bartlett's test of sphericity. Now, Bartlett's test is a statistic used to examine the hypothesis that the variables are uncorrelated in the population. In other words, the population correlation matrix is an identity matrix. Each variable correlates perfectly with itself but has no correlation with the other variables. Well, if it does not have any correlation with other variables, there is no point doing factor analysis, because then you can't group the variables together. A value less than 0.05 indicates that the data in hand do not produce an identity matrix, which means that there are significant correlation between the variables and that yes, they can be grouped together. A significant, that is less than 0.05, indicates matrix is not an identity matrix. That is, the variables do relate to one another enough to run EFA. So your Bartlett's test should be significant. Commonalities. Commonality is the amount of variance a variable shares with all the other variables being considered. This is also the proportion of variance explained by the common factors. So how much variance does this one particular variable share with all other variables that are being considered for exploratory factor analysis? Now this has to be high enough. This has to be over 0.60. They should share some common variance in order to develop the factors. Another thing that you get is uniqueness. It gives the proportion of common variance of the variable not associated with the factors. This has to be low. It has to be, the uniqueness of a particular variable has to be low. Its commonality has to be high. That is the reason that you will get a clear factor structure that shows that one particular variable is associated with the other variables in the data set. Now uniqueness is equal to 1 minus commonality. So commonality is 1 minus uniqueness. Percentage of variance. It gives the percentage of variance that can be attributed to each specific factor relative to the total variance of all factors. So if we get multiple factors through our EFA, how much variance is accounted to a particular factor? Eigenvalues. The eigenvalue represents the total variance explained by each factor. Factors having eigenvalues over 1 are selected for further study. Now you get to know, or you should know, how many factors you should extract or how many factors could be extracted. Normally what we do is all those factors that have got value or eigenvalue over 1 are actually selected for further study. This is a rule of thumb. Scree plots. It is a plot of eigenvalues and factor number according to the order of extraction. This plot is used to determine the optimal number of factors. Well, same as eigenvalue, it helps in determining the number of factors. But the easiest way is to go for eigenvalues. Select all those factors that have got eigenvalue over 1. Now factor loadings, also referred to as factor variable correlation. Factor loadings are simple correlation between the variable and the factors. Or what it does is it represents how well a particular item is representing the underlying construct that is established through exploratory factor analysis. Now factor matrix. A factor matrix contains the factor loadings of all the variables on all the factors extracted. So it's a sort of a table where you get all the factor loadings for all the variables or items that have been obviously subjected to exploratory factor analysis. Now this is particularly important. What rotation method shall we use? Now what it does is it gives you or makes the loading patterns easy to understand. It establishes to which particular dimension, to which particular factor a particular item would belong. Now Varimax, this is the most common method used, highly used, and most of the scale development papers that you will see or come across will be using Varimax. Now what it does is it minimizes the number of variables with extreme loadings, high or low, on a factor. minimizes the correlation between factors. What it does is it minimizes the correlation between factors. So what you are assuming is that these factors are independent of each other. Now what it helps is it makes it possible to identify a variable with a factor. Components are always orthogonal. Each component explains non-redundant information. This is why we go for Varimax. So that we are saying that these components are actually not related to each other. They have got their own individual existence. The next is Quantimax. Minimizes the number of factors needed to explain each variable. Tends to generate a general factor on which most variables load with medium to high. Now this is not very helpful in research because what we are interested in is identifying factors that actually lead to the explanation of the underlying construct. This is another method that is very widely used. Now the difference is that factors are allowed to correlate. This is its difference with Varimax. Here you are minimizing the correlation between factors, but here in direct oblimin they are allowed to be correlated. The next is Promax. Use it when you are not sure. So conceptually faster than direct oblimin, and it's always used for a larger data set. And the last is SimplyMax. It obviously generates a more simpler structure. But what I would suggest is go for Varimax because it's been widely used, extensively used in scale development papers. Rotation that allows for correlation are called oblique rotations. Rotations that assume that factors are not correlated are called orthogonal rotations. Obviously, these are the terminologies you might come across if you are reading EFA. So Varimax is orthogonal and direct oblimin is your oblique rotation. So we will go for orthogonal rotation. Or obviously you can try and test both of them. Varimax returns factors that are orthogonal. Oblimin allows the factors not to be orthogonal. Now how do you run factor analysis in SPSS? You go to analyze, dimension reduction and then factor. And you will come across the same terminologies that we have discussed previously. But in this case we will be using Jamovi. So in order to run it, just open the dataset in Jamovi. If you have not used Jamovi, just go to the previous videos available on YouTube. Have a look how to download it, how to access the data. It's very easy to use software, something very usable. So what you can do is, or what you should do is, since we are focusing on principal component analysis, a method in exploratory factor analysis, we go to factor and principal component analysis. Well, Jamovi takes it separately to exploratory factor analysis, but in SPSS, it's one of the method in EFA. So we'll go for principal component analysis. What components exist in the data? Now let's talk about the data bit. This is the data that I collected for one of my scale development studies on CSR. So development responsibilities, ethical responsibilities, relational responsibilities, and information sharing responsibilities. These are the 4 dimensions. Now, in order to run, we'll go to factor, principal component analysis, because we are interested in identifying the components that can be extracted from this particular data. So what we have here is we have around say 7 and then 5, 12, 18, 27 variables, and we are using principal component analysis in order to summarize these 27 variables into smaller set of components. So what you should do is just select these variables and put them in. Select all these because you believe that these are the items measuring a similar or same construct, but they have got different components in them. If you look, it's showing that it has got 2 components in here. But this is parallel analysis. We are not doing parallel analysis. We are going to go for eigenvalue. So eigenvalues greater than 1 will become a factor. It's loading. And now if we see a more disturbing sort of picture. It's not that clear that we see in a research paper because we haven't hidden the low loadings. So let's hide the loadings less than 0.5. because obviously each item should adequately represent its underlying construct. Now, if it does not represent adequately its underlying construct, obviously it should not be part of that particular dimension or that construct or that factor. But if we just turn to 0, we'll see the whole table filled in. This is similar to cross loadings in Smart PLS. So what we see is DE1. To which component does it belong? This belongs to the second component. So we can say this second component here is your development responsibility or developmental responsibilities, because all these 6 or 7 items from development are loading onto this particular factor, factor 2, because DE1 is not loading well onto factor 1, not on 3, not on 4, and same is the case with other ones. Let's see ET. ET is loading well onto factor 3, ET1. Same as ET2, same as ET3. So these 5 items are actually or can be grouped together into a single dimension, into a single factor. So in order to get a clear factor structure, what we do is we change it to 0.50. And now have a look and you'll get a more clear factor structure. And we'll be coming back in onto this because DE7 is not loading anywhere, same as REL6. But let's see some other things here as well. Let's say KMO in Bartlett, let's say KMO measure of sampling adequacy. And if you see, this is not an identity matrix. There is correlation between factors. That's the reason they are grouped into a component. So this assumption is checked. You see, overall measure of sampling adequacy is way greater than 0.5. So no problem whatsoever with your sample. Now there are other things that you can do as well. Let's say go for component summary, because correlation matrix won't matter because the correlation is minimized. If you want correlation, you can transform each of these components and calculate correlation separately using Pearson correlation. Now component 1, it's explaining 18% of the variance, 2 15%, 3 12%, 4 12%. The total is 57.8%. So when you take out these components from this particular data, these 4 components are explaining at 57.8% of variance in the underlying construct or underlying scale of CSR, which is good enough, which obviously it's greater than 50, so it's good enough. Now let's say, what is this? Okay, this is uniqueness. In SPSS you normally get commonality, so 1 minus uniqueness will be your commonality. So if we see the commonalities here, just do 1 minus, so you'll see good commonalities, not that kind of problematic. But the problem is D7 is not loading onto any factor. So what we do is we remove the D7 because it's not loading, it's not representing any of the component, any of the factor, so you remove it. And this is what I like about Jamovi. Automatically does this stuff. And see now, but again REL6 is not loading well. So what you do is go to REL6 and remove it. And what you get is a more clear factor structure. Component matrix, your assumptions, your KMO measure of sampling adequacy overall for each item as well, but obviously you just need to report the overall measure of sampling adequacy. You can get a correlation, you can get the eigenvalues as well, you can get the Screeve plot. Let's go for component correlation, but this won't make any sense because it's minimized. See, the eigenvalue suggested 4 factors, so we've got 4 factors here. Screeve plots, so normally you would have read in the books wherever the elbow breaks. So let's see where the elbow is breaking. Okay, so it's saying somewhere here it's the line is going, it's breaking. So but this is not very meaningful to everyone. That's why we've got this one here, eigenvalues. So I always use this, so use this. Now you can obviously load loadings by size, but obviously that would mix the stuff up, so just keep it like this. Now how do you report these results? So let's go and report these results. Now before we go on to report the results, there's one important thing to consider. Now we deleted these 2 items because they failed to load. Sometimes you will have a situation where an item loads well onto 2 or more factors. For example, let's say DE6 might have loading 0.50 on factor 2 and maybe on factor 4. So this is cross loading. Again, it is advisable when you are building a building a scale, you should get rid of such items. Now, how to report the results. Here I've created a template. An EFA was performed using principal component analysis and Varimax rotation. The minimum loading criteria was set to 0.50. The commonality of the scale, which indicates the amount of variance in each dimension, which was also assessed to ensure acceptable level of explanation. The results show that all commonalities were over 0.500. Now if we look here, 1 minus uniqueness, we see all items have got commonality greater than 0.5. So we are retaining all items. The next step is your assumptions. So the first step or the first assumption is Bartlett's test, which shows that this was not an identity matrix. So the results were significant. So you report the chi-square, n value, and the, so where is this? This is, obviously you need to change the values. This is just a sample. So chi-square value is this, the p value is this, the degree of freedom is this. So we will change these values. Obviously this description is available on the Google Drive, and the link will be in the description. So the MSA values required to be over 0.5, and this is the MSA value. So just change your values from here, and this is the variance that we obviously showed. Okay, now yeah, this total variance 58.8. Moving on, if you deleted a few items, which items were deleted and why those items were deleted? And once the items were deleted, what was the KMO value? So what you do here is you report the initial EFA results, then you remove the items, and then you remove the KMO value, report the KMO values and the identity matrix. And finally, it was a 4-factor solution. Obviously, you will change as per your requirements. So how the 4-factor solution and what items were there in each of the factors. So this is how you can report your factor analysis. I'll also share some of the papers in which factor analysis is reported. So this will help you as well. Thank you very much.